So, hello everyone. I am Serena Curzel. I'm a third-year PhD student, and I'm presenting my research on modern high-level synthesis, improving productivity with a multi-level approach, or as I'm going to call it today, because this is not an academic conference, the future of high-level synthesis. So first, I have to define what is high-level synthesis. This is not a common term for everyone. Basically, whenever we have an algorithm and we realize that it cannot be executed with enough efficiency in terms of power or latency maybe on a regular processor or GPU, we may want to implement it as a hardware accelerator. To do that, we either need to write HDL code, which is a process that requires hardware design experts, time and money, because it's a programming model that's very far away from regular software, or we can benefit from high-level synthesis tools, which have been around for roughly 20 years, and they allow software programmers to write plain C, C++ code, typically, and automatically translate those into an HDL description that is ready to implement the actual accelerator. Nowadays, high-level synthesis is not enough anymore, and actually my fellow student just provided a perfect use case. We have, for example, bioengineers or medical imaging experts that do not write C or C++ software. They write their machine learning algorithms in high-level languages such as Python, and they use these frameworks like TensorFlow and so on. They are quite far away from what is C and C++ software. So we would need what my colleague calls ninja programmers, so someone who can both write efficient HDL code and also understands high-level algorithmic implications. High-level synthesis can help reduce this gap, but it still doesn't cover it completely. So we can generate efficient accelerators from C++ code, which has some HLS annotations, but still we need an expert HLS developer that bridges the gap between this kind of annotated code and the high-level algorithm. And there are some solutions around. This is what I call like my competitors. There are tools and research groups that have built libraries of HLS templates that are extremely optimized. And so you can take a high-level applications and map it on those templates and then send it to HLS. This, however, has pure limitations in flexibility and scope, because whenever there's something new on the algorithmic side, you need, again, an expert HLS developer to write a new class of library templates. So the solution that I helped, that I contributed to in my research group, is different. It's called SODA, which stands for Software-Defined Accelerators or Software-Defined Architectures. And it is based on the idea of using a compiler-based toolchain that doesn't require an expert HLS developer. And we can offer this toolchain to domain experts, and they can use compiler passes and options to easily analyze, explore, optimize their algorithm, and then the HLS engine is integrated in the framework and generates the accelerator design. A bit more details about SODA. SODA doesn't require any manual coding, any manual intervention on the algorithm code. It facilitates the exploration of different design trade-offs. It can generate code for both the accelerator definition and the host processor that will drive the accelerator. And it is easily extensible so that also HLS developers can benefit from it, and they don't need to have access to the internal code of the HLS tool to experiment with new optimizations. So this is the future of high-level synthesis. It can, on one side, answer better to the new challenges and the new requirements of today's applications, such as artificial intelligence or the Internet of Things. But on the other side, it doesn't throw away 20 years of HLS research. We still want to exploit HLS tools as much as possible. And this is going to be an invaluable tool for both domain scientists and HLS developers and researchers. Our team has a strict collaboration with the Pacific Northwest National Laboratory in Washington State, USA. This is where I also did an internship. And this is our main achievements in terms of publications, and everything is open source should you want to have a look at our code and contribute to it. So I'm looking forward to keep working on this toolchain because I think it will really provide amazing opportunities for the future. Thank you.
Which is given by Nicola. Increasing human-robot awareness for better cooperation in collaborative